Welcome to clickmyproject.com. Now let me see about query adaptive image search with hash codes. Now let's see the abstract. Here, scalable image search can be performed in the humming space using humming distance. We propose a novel approach that computes query adaptive weights for each bit of the hash codes. First, for images, we calculate finer grained hash codes level with the bitwise weight. Each hash code is expected to have a unique similarity to the queries. The result can be rapidly ranked by the weighted humming distance. And then we calculate the scale invariant feature transform is an algorithm to detect and describe local features and images. It's the method for image feature generation, transform an image into a large collection of feature vectors, each of which is invariant to image translation, scaling and rotation, partially invariant. The minimum distance index images are retrieved from the database. Initially, we remove the noise from the image by the use of Gaussian filter. Gaussian is the window filter of linear class. By its nature is weighted mean. After that, we extract the shift feature and then hash code is generated for query image as well as the database images. Based on the similarity, finally it retrieved the images from the database. This is the flow of our process. Here we are having two stages. First one is the training stage and second one is the testing stage. In training stage, we have to train the whole database images. From the trained features, the testing features will be retrieved. Okay. Here we are giving the whole database images and then the given database images will pass to the pre-processing step. In this stage, we are applying the Gaussian filter. It will remove the Gaussian noise. Gaussian filter is windowed filter of linear class. By its nature, it will be remove the noise based on the weighted mean. After remove the noise, it will pass to the shift feature. Shift feature is an algorithm in computer vision to detect and describe local features in images. For any object in an image, interesting points on the objects can be extracted by the feature description of the object. This description extracted from a training image can then be used to identify the object when attempting to locate the object in the test image. After that, it will go to the hash code generation. Hash function is an algorithm that maps data of arbitrary length of data in a fixed length. The value written by the hash function are called the hash values. It is the method of performing probabilistic dimension reduction of high dimensional data. The basic idea is hash function is input items so that similar items are mapped to the same buckets, and then it will go to the humming distance. For the humming distance, we are giving the input to the test features will given as a input to humming distance. The humming distance between two strings equal length is the number of positions at which the corresponding symbols are different. Then the humming distance between the two words is the number of edges in the shortest path connecting the corresponding verticals. The extracted humming distance will pass to the retrieval. Here we are identifying the relevant images based on the similarity, and then the relevant images retrieved from the database. Now let's have a demo of our process. Here I am having main.m file. Select this file, right click and run the file. This is our guide design. Here we have to given the input image. In dataset, totally I am having 4 category of images. First one is building, second one is bus, rows and horse. These are the dataset images. Now I am providing one category image as building. The selected image is displayed in the first axis, and then we are going to pre-processing. Here we are doing gray conversion and filtering. For filtering, here we are using Gaussian filter. It will remove the noise from the input image. After removing the noise, it will go to the shift feature. Shift is represented the scale invariant feature transform, and it will also extract the local points in the image. This is the located points in the image, and then these are the feature values were extracted from the shift algorithm. And then here we are going to identifying the hash code. The hash code is generated now. After identifying hash code, it will go to the humming distance. These are the humming distance values of the input image. The input image of the each category images is displayed in the second table. After that, based on the distance, it will retrieve the relevant image from the database. These are the retrieved relevant images from the database. And then here we are going to the analysis step. Here we are showing the precision recall graph. In precision recall graph, we are showing how much false positive and true positive rate is there. Here the precision is high. Precision is represented true positive, and recall is represented the false positive. So here our true positive value is high. Here I am showing the result of query adaptive image retrieval based on the humming distance. The humming distance will retrieve the images better than the existing system. Thank you.